Okay, so in this video, I just want to introduce the idea of vectors, and we'll make this idea more concrete in class, but I just wanted to introduce the idea here. So what is a vector? Vector is a quantity that has a magnitude as well as a direction associated with it. Okay, so there are scalar quantities and there are vector quantities. Scalar quantities, I think most of everybody is familiar with. So for example, mass is a scalar quantity. Okay, there's no direction associated with mass, it's just a number. Okay, similarly with time. Time is a scalar quantity, temperature is a scalar quantity. So these are quantities that just have a number associated with them. Okay, vector quantities are quantities like displacement, velocity, force, right, acceleration. All of these quantities, they have a number associated with them as well as a direction associated with them, right? So we just want to understand the general idea of a vector here. So what you see here is a vector, so it's some arbitrary vector that I've drawn, and I'm calling this vector A. So the way we represent vectors in physics is we write the vector, in this case A, and we put an arrow on top of that. So this is my representation of the vector A here. All right. So the vector has what's called a tail, and it has a head. So the head is wherever the arrow is, so that's the head of the vector, and wherever there's no arrow, that is the tail of the vector. Okay? The magnitude of the vector we can write in two ways. So the magnitude we can write as you see here. So we put the vector A and put two bars, the absolute value symbol here. So we can write the vector A, the magnitude of the vector A this way. Or we can just write the letter A without the vector sign on top of it. So without the vector arrow on top of that. And that will also represent the magnitude of the vector A. Okay? So sometimes I'll be using this, sometimes I'll be using this in class to represent the magnitude. Okay? So this is how we represent a vector. Now what happens if you take a vector and you multiply it by a scalar? Scalar meaning just a number. So if you take this vector A, which has some length, okay, in this case I have taken A and I have multiplied it by 2. So that's just going to increase the length of this vector by 2, right? So this vector 2A is now going to be twice this length. Okay? That's going to be twice the length. If you had 3A, it will be 3 times the length of this vector, and so on. Okay? So when you multiply a vector by a scalar, it will just increase the length of the vector. All right? Another thing I will mention here is that what if I want to find if negative A? Okay, so negative A, what's going to happen with negative A? Negative A will just flip this vector 180 degrees. Okay, so if I want to represent negative A, let me find a ruler. So negative A in this case, right, I can just draw it like this. Okay, so this will be negative A. Okay, that would be negative A. It just goes the opposite way, right? Right? So this is how, this is the result of multiplying a vector by a scalar. All right? So the next thing we want to talk about is how do we add vectors graphically, add and subtract vectors graphically. So there's two ways of adding and subtracting vectors. One way is the graphical approach, and one way is the algebraic approach, which is more useful. And I will talk about that in a bit. Okay, but let's understand how to add vectors graphically, because this is something that we need to be able to do in physics. So what you see here are two vectors, A and B, and I want to add these two vectors together. Okay, so I want to find the sum R, which is A plus B. So how do I add these two vectors? What I do is I draw the first vector, okay, which is A, and to the head of A, I put the tail of B, okay, and my sum is going to go from the tail of A to the head of B. Okay, so that's a lot of words, so let's understand this graphically. So I take A, I draw A first, so this is that vector, this is what you see here. Okay, then I take the tail of B, and I put it to the head of A. Okay, so I've transported this vector, the tail of this vector, to the head of this vector. And that's what you see here. Okay? Alright? And the vector R is going to go from the tail of the first vector to the head of the last one that you add. In this case, the last one we're adding is just B. So it's going to go from the tail of A to the head of B. Okay, so I hope that's clear. So this is how we add vectors graphically. Draw A, to the head of A, we put the tail of B, and the sum R is going to go from the tail of A to the head of B. Okay, and this approach works with any number of vectors. Okay, it works with any number of vectors. So for example, what you see here are three vectors. I have vectors A, B, and C. Right, now I want to add three vectors graphically. It's the same thing. So I will start with A. Okay, I draw A. To the head of A, I put the tail of B. So this is what you see here. I put the tail of B here. It goes in the same direction, right? I have just transported this vector to the head of A. Okay, so I've transported the tail of this vector to the head of A. So that is what you see here. And then in this case, I have another vector, which is C, that I want to add. So now I will take C and I will put the tail of C to the head of B. And this is exactly what you see here. Okay? And the sum is going to go from the tail of the first one to the head of the last one that I add, which is in this case C. So this is the vector sum. Okay, this is the vector sum there. So I hope that's clear. What about if I want to find R, but this time R is A minus B? Okay, so what do I do now? So if I want to find A minus B graphically, so these two vectors I have, A and B, but now I want to find A minus B. So I will do the same thing, right? I will start with A, but this time I will add negative B to that. And as we said, that if you want to find minus B, you have to flip this vector 180 degrees, okay? It's going to go, you have to flip this vector. So here's my vector A, and to the head of A, I add negative B. So I put the tail of negative B here. Okay, the tail of negative B. So now this is A plus negative B. And then the resultant is going to go from the tail of the first, which is A, to the head of the last one, which in this case is negative B. So this is how we represent the resultant in this case. Okay, this is how we represent the resultant vector. Okay, so A minus B is the same thing as A plus negative B. Okay, A plus negative B. All right, so I'm going to stop the video here, and in the next video I'll discuss a little bit further.